Welcome to the Red Couch of Published Industry. This is our live talk, live from Electronica. I'm Christian Fischbach, the Editor-in-Chief of E&E, Fascination of Electronics. And today we're talking about enabling future grids. I'm proud to talk to Kripa Venkat. He's General Manager, Grid Sector at Texas Instruments. Hello, Mr. Venkat.
Hi, Christian, and good afternoon to everybody here at the audience. Thanks for the introduction. So I am working for Texas Instruments, and I am the General Manager for Smart Grid and Energy. And I'm here to talk about it and to make sure that people understand how important Smart Grid and Energy is, not only for silicon vendors, but also for consumers, utility companies, and the others.
So, Mr. Venkat, talking about smart grids, what makes the grid smart? What's the main technology behind smart grids?
So anybody who works in the smart grid industry will pretty much agree with me. For some of you who are not very familiar with smart grid, one of the most important things that makes the grid smart is communication and control. So if you look back, 5, 10 years ago, maybe even 15 years ago, meters had electromechanical parts. They did not have any sort of communication. The first thing that happened was meters started to move from electromechanical to electronic. And by doing that, there were a lot of advantages in terms of accuracies and things like that, lower cost and more predictability, less calibration needs and so on. After that, they started introducing something called AMR, automated meter reading. That will help people read remotely from meters, but this was unidirectional. All you could do is have a meter, and then you will drive past, and then somebody, instead of actually going up to the meter, can take the reading from fairly 100 to 200 feet away, and that was enough at that point in time. Now, today, what is most important is this unidirectional communication is not enough. They want to do more, and there are reasons for it, which I will cover during this session. The most importantly, right now, smart grid needs to have an automated metering infrastructure, which includes a lot of things, not just reading from the meter.
So you come to visit us from Dallas. Are there different demands on smart grids in the US than in Europe?
It's an interesting question, and I think Europe is very diverse, not as diverse as Asia and some of the other regions. However, when you look at the US and Europe, one thing that is really important to note here is, if you look at developed countries, so the US is a developed country, so is Germany, most of Western Europe is developed. And if you look at the grid 10 years, 15 years ago, you'll find that all of these grids were the best in class. Unfortunately, what has happened is some of the developing countries have found the need for a smarter grid. So this is the first time they are even trying to improve their grid. So today, some of the developing countries have a better grid compared to the US or Western Europe, for example, because they are starting only now. However, US and Europe are picking up Western Europe, and the need is mainly for making sure that the grid is resilient to different types of attacks. Once you have communication, once you have control, you really need to make sure that the grid is safe, not only from any kind of failures, because nobody likes to have a power failure when they're watching their favorite game. I mean, Germany won the World Cup. Would you have liked it if you had, a power outage when you're watching the game? You don't want to do that. The same thing is true. So having continuous power supply, not only for entertainment, but also for industries. Most industries have a way to have backup supplies and so on. But what about small-scale industries? They don't like to have uninterrupted. They would want to have uninterrupted power and so on. And then you have medical equipments. You don't want a person who is living on a life support to lose power and things like that. So the needs are growing to make sure that the grid is resilient in terms of function. And also cyber attacks that you see on your internet, those things can also happen now to the grid, because at the end of the day, the grid is also a network that needs to be protected. So the needs are growing also to make sure that the grid is resilient. Other needs that come out of this is energy conservation is very important. The population of the world is increasing, the energy needs are increasing. Everybody has a smartphone, for example, and every smartphone needs more power than what an old mobile phone needed. Or even, go back 20 years, we didn't have all these smartphones or even a mobile phone, and they didn't need the power you need. So everybody now is using more power than what is available. So we need to find ways to integrate renewable sources of energy. So the grid has to understand the need of using conventional forms of energy integrated with renewable sources to make sure that there is constant power and the needs are met and there is no shortage of resources moving forward.
So Mr. Venkat, to reach or to meet all these demands, what innovations did Texas Instruments contribute to the smart grids?
So Texas Instruments, for people who have been used to calculators, Texas Instruments is more than 75 years old, and we were silicon vendors. We still are silicon vendors. So our biggest task a few years ago was to sell chips to manufacturers to manufacture different applications, to manufacture different equipments for automotive, industrial, name it, and you will find that there is a TI chip inside it. Right? That's great. However, what is happening is there was a lot of innovation with it. We still do innovation, but if you think about cost, there are different ways in the past how things were done, but we're adding more functionality, but then we don't want to increase cost. So innovation is at the heart of any kind of low-cost solutions. So if you look at more functionality, we have ways to add more cores, more CPUs, more horsepower, so that more processing can be done. And then we have RF technologies, we have different memory technologies, which will make sure that the equipments that you manufacture are safe and things like that. So that is on the silicon side, how TI has contributed to smart grid. If you look at another way, today we see a lot of customers who are not just looking for chips, they're looking for solutions. A solution is where you have more than one or two chips talking to each other. It's not just silicon, there's probably a good amount of software that needs to run, there are features and so on. So TI has also found a way to innovate in terms of system solutions. TI has a big portfolio, analog, digital, RF, power, there's so many things in TI, but at the end of the day, as a customer, they would like to see us provide a solution that has all of these chips working together. This is the most important innovation that TI brings on the table for the smart grid industry as well, because if you, for example, go to the Texas Instruments booth, you'll find out we are showing you system solutions. We don't have data sheets, we don't have chips lying around, we have systems, we have system solutions lying around there, showing you how you can solve a particular problem in an application. So this is the same thing for smart grid as well.
Yeah, talking about these solutions you offer, how important are communication technologies to the smart grid?
It's extremely important. I think a grid is smart only when it has communication. So I told a little bit about the different topologies that TI is focusing on. But if you just look at the grid, so just like any other types of communication, you're going to have wired communication, so for connectivity, right? So we have Ethernet, we have USB, and then all different types of industrial interfaces like Profibus, DLMS, those kind of protocols, IEC 61850. I don't want to go too deep into those details, but these are things that are required. And then we also have wireless communication. So any form of communication that you need, it can be wired or wireless. So there's RF technologies as well that TI has, 2.4 gigahertz, 5 gigahertz, Wi-Fi, Zigbee, sub 1 gigahertz, anything that needs you to connect to a meter, TI has a solution. One of the most important thing also to note is, also just like how you want to have uninterrupted power, the utility companies want to have uninterrupted connectivity to these meters. They want to make sure that the meters are connected. They want to know if the meter is working well. They want to know if the meter is not being misused, right? And for all that, they would like to have 100% reliable communication. So I think TI has some very good solutions for robust communication, both on the wired and the wireless side.
Yes, so to come to the most important question as far as I'm concerned, what value to the end user does the smart grid offer?
This is a very interesting question because if you go back in time, maybe 2 or 3 years ago, in fact, inside of Texas Instruments, I would have colleagues. TI is a big company, and you have different people working in different areas, and I would have TI colleagues coming to me and say, oh, you're in smart grid, okay. I mean, how is it good for me? What is in it for me? I think at the end consumer level, the biggest problem that people feel is that they are paying for smart meters, but they're not getting anything back in return, which is not true. If you think about it, I talked about renewable sources of energy, how integrating renewable sources of energy like solar and wind, along with conventional sources of power, if they're combined, it will make the grid, safe from power outages, right? Think about it. If they integrate renewable source of energy well, the total cost to generate power is going to be less. With that, it's going to bring down your bill as well. So having a smart grid, ability to combine these sources of energy, at the end of the day, will have a less bill as a consumer. So this is important, the first thing, right? The second thing is, think about it. If you're sitting in your house, right, and you're consuming power. I mean, my wife always tells me that, oh, the TV is always on, or something's on and I need to turn off the lights. But if there is a way for me to see how much power is being consumed when I turn some things on and off, I will know how much energy is being wasted. As a homeowner, if you are sitting inside your house, your meter is able to calculate how much energy is being consumed. You come and look at it. It's a touch screen panel. You can come and touch, and it tells you how much energy is being consumed. Now in fact, we also have intelligent in-home displays that will also tell you how much money you're paying at any point of time in your day. So when you look at that, immediately you realize that you are wasting power. You can conserve power. When you conserve power, you're again saving on your energy bills. And that is very important. The same thing can happen when you're sitting in a remote location. Say you're driving to work and you're at work, and the thing is, when you come back home, and in Texas, for example, we have very hot summers, 38 degrees, 40 degrees, 42 degrees, and the winters sometimes are cold as well. We don't get snow a lot, but it does get cold. So think about it. So I have to keep my air conditioning on at fairly a good temperature so that when I come back home, the house is not, like an oven, right? And then the same thing is true when I come home in winter, right? Think about the ability for a homeowner like me that I know I'm going to leave work at 6 o'clock in the evening. I can, with the click of a button, either through the web or the phone, whatever it is, the click of a button, I can turn on or turn off my air conditioner the way I want. Supposing I have a dinner that I didn't plan, I don't have to turn on my air conditioner till I go home, or my heater. That's savings as well. You're not wasting energy when you're not in the house. And then there are other times where, like at least in Texas, energy is not that expensive, but in California, where energy is expensive, they have different pricing for different times of the day. So, at maybe 6 o'clock to 7 o'clock is most, pricey. After 7, it goes less. Maybe, you can, program everything in such a way that you take advantage of dynamic pricing. So again, you save cost. So at the end of the day, I think if a homeowner is concerned about what is in it for him, I think there's a lot of benefits. Of course, at some point in time, smart grid will move. I mean, today in some countries, smart grid is moving from automated meter reading to automated metering infrastructure. When it becomes an automated metering infrastructure, that will help you realize a lot more savings than you normally would. Because right now, I think some countries, the utility companies are benefiting because they don't have to send people right to the door. They can probably read the meter remote. And that's the only advantage that consumers see. And they believe that there's nothing in it for them. But think about all what I said. There's definitely more savings to the homeowners than you think.
So a lot of these benefits are actually connected to smart meters. We talk a lot about smart meters, but still we don't see a lot of them in Germany. Are other European countries better or faster in implementing smart meters?
I think, like I said before, I think Germany is there. It's not like Germany is not deploying smart meters. I think the level of smartness is what is important to note here, right? So I talked about automatic meter reading. So, for example, in Germany, I think the deployment of smart meters happened quite early, but the functionality of the smart meters is not as high as you would see it in France or Spain, for example, or even Italy. I think there will be a day where, it's again, what is the need, If there's a need, then I think different countries would deploy it. So in France, for example, 30%, and when I say smart grid, I also include any type of utility. It could be any kind of source of energy. Even water is actually a source of energy. Even gas is a source of energy. So if there's a lot of leakage, if there are a lot of losses, right, in the grid, things like that, maybe there is a need to deploy smart meters much faster and much more functional than you would see in Germany. So I would not 100% agree with you, Christian, that there's not a whole lot of smart meters. There are, but maybe they're not as complicated, as complex as you would see in some of the other regions. But I'm confident that there will be more. Yeah.
You're confident? How do we get there? Do you have any suggestions for the German utilities?
I think the most important thing is we have to find a way to, to talk to the utilities and find out where are they losing the money. For example, the audience, some of you may know that today, when you pay your bill, you're only paying for the active energy. Okay? You are not paying for the losses. So if you have 20 motors, say you're running a garage and you have a garage or some kind of small scale factory, right? You're only paying for the active power that's being consumed. So if you have a lot of motors, there's a lot of losses in those motors. No one's paying for that. When you have smart meters, you actually can easily identify what you have consumed in terms of active and how much losses you have created. So the energy company does not have to feel that they have lost money because of the loads that you have. So I think the utility companies need to spend some time and look at how much energy they are losing in transmission, in distribution, how much energy is being lost because of bad loads at consumers. At the end of the day, that is the biggest need for the utility companies to do to make sure that they identify how much money is being lost, how much energy is being lost. And once they do that, I think the answer will be very clear that there will be need to deploy more and have more functionality.
So Venkat, much thanks for these insights, interesting insights on the smart meter and smart net subject. Thank you.
Thank you, Christian.